All right, so in our third lesson, we're going to talk specifically about some of the sampling techniques that we did in our random rectangles activity the other day in class. And so this is going to be simple random sampling. All of them are simple random sampling, but then there's specific techniques, and those techniques are going to be cluster random sampling, stratified random sampling, and then systematic random sampling. So let's talk about each one of these so that we have a really good idea about what these involve. So the first one that we're going to do, is systematic random sampling. So this is where you divide the entire population size. Like we had 100 rectangles. We divided the population size by the sample size. Our sample size was going to be 5. So we took the population size of 100, divided it by 5, and got 20. And so our M would be 20. And then we wanted to find a number to begin with between 1 and 20. And so we used our generator on our calculator to do that. And we could call that number the number K. So suppose that that is the number 7. So we would start by picking the 7th rectangle, and then it says select the for the sample those numbers of the population that are numbered as K, and then K plus M, which would be 7 plus 20, and then 7 plus 40. So we would have 7, and then 27, and then 47, and 67, and 87 would be our sample size. Let's see how that would work in a situation like this. Suppose there are 2,400 students at Homestead High School, and you want to create a study to find out how many hours Homestead students spend on their phone each week. So you decide to ask 50 random students. Okay? So we want to do this as a systematic random sample. So the first thing that we would do is we would take our population, which is 2,400, that's our population size, and we would divide it by our sample size, which is 50. And so that number that we get is 48. And so we're going to get a number somewhere between 1 and 48. Suppose that we get a random number, and let's say that it happens to be 30. So 30 would be, we would find the 30th student. Of course, we would have to number all the students first, but we would find the 30th student first. That's going to be our K value, and it just has to be between 1 and 48. Well, then to find our next number, we're going to actually add 48 to that. So our next student would be student number 78. And we would just continue to add 30 plus 48 as many times as we wanted to until we ran out of people to ask. So we would ask the 30th number, or the 30th student. We would ask the 78th student, the 126th student, if we keep adding 48. If I add 48 again, I'd ask the 174th student, and I would keep going until I run out of students, until I'm over 2,400, and that should give me 50 random students. This is an example of simple, systematic random sampling, and it's just a systematic way to get random numbers out of a population. All right, so let's take a look at the second type of random sampling, which is cluster sampling. So in cluster sampling, we divide the population into groups or clusters. We did this on our sheet of rectangles. We just divided them into 5 equal clusters or groups. And then we obtain a simple random sample of either one cluster or several clusters. And then we use that random sample of those clusters and apply it to the entire population. So how would we do that on our situation here at Homestead High School? There are 2,400 students. We want to come up with 50 of them, but we want to do it by clustering them. And suppose the clusters that we pick are specific classrooms. And suppose that there are 25 students in a classroom. So we would cluster them by classrooms, and I couldn't just come up with a random sample of one classroom because I'd only have 25 students and I really want 50 of them. So what I'd probably do is go to 2 different classrooms. Randomly go to 2 different classrooms and then survey the people in those 2 different classrooms to get a total of 50 students, and then apply that, whatever I'm studying, how often they're on their phone, to the entire population. That's an example of cluster sampling. A lot of people get cluster sampling and stratified sampling confused. Stratified sampling is where you put the entire population in groups, but you put it in groups by a certain characteristic called a strata. This is what we did with the rectangles when we had the small rectangles on top, and then the bigger rectangles below that, and then bigger ones below that, and the very biggest rectangles on the bottom. So a strata could be what class they're in, freshmen, sophomores, juniors, seniors. It could be what area of the building they're in, if that would be a characteristic that would lend itself to whatever it is that we're studying. So let's do this with this example again. Same example as before. There are 2,400 students at Homestead High School, and we want to create a sample of 50 students to find out how many waking hours students spend at home. There might be a difference between freshmen, sophomores, juniors, and seniors, and so I'm going to pick that as my strata. And suppose there are 700 freshmen, 600 sophomores, 600 juniors, and 500 seniors. And so we have the population broke up into 4 different strata, and then I want to select certain students from each strata. Okay, so I want to select so many freshmen, so many sophomores, so many juniors, and so many seniors, but I have to do it proportionally. Okay, a proportionate size. So because there's more freshmen, I should probably have more freshmen in my survey. And so to do this, I would have something like this. I want to select 50 out of 2,400 students. Well, using that same proportion, how many freshmen would that be if there are 700 total freshmen? So I would have to solve a proportion like this. And hopefully we remember that to solve a proportion, we're going to cross multiply. I'm going to take 50 times 700, which is 3,500. That's 3,500. That's this cross product. That's going to equal the other cross product, which is 2,400 times x. So then I'm going to divide by 2,400, and that's about 14.58 people. Now I'd have to round this. I could round it up or down. So suppose I would ask then 15 freshmen. Okay, and I would do the same thing to figure out how many sophomores to ask and how many juniors to ask. Now my sophomores and juniors have the same number in them, so the same number, if I ask 12 sophomores, I would also ask 12 juniors, and so on. But it should be less than the number of freshmen because I have a bigger total of freshmen, so I should have a bigger total in my sample that represents the freshmen in order for that sample to be representative. That's an example of stratified random sampling, and you break it down into groups that are called strata based on strategy you can think of, which is a particular characteristic that might lend itself to having different answers based on what you're looking for in your sample. That is assignment 1.3, specifically those different sampling techniques, which we did yesterday in our random rectangle activity. And that's also what our homework assignment is going to be on in Math Excel. Let's do that assignment, and then we will gather back up after everybody's finished with that assignment and go over questions again.